Hello, in this video we'll study the stereoisomerism, the types of stereoisomerism. One is geometrical isomerism. Well, for the geometrical isomerism, the compound should have a double bond. And when a compound having a double bond between the carbon atoms, the molecular structure will be a planar structure. And when it is a planar structure, there is a difference in the arrangement of groups in space. Well, here it is said geometrical isomerism arises due to restricted rotation across the carbon-carbon double bond. When there is a double bond between the carbon atoms, there is a rotation is hindered, and therefore whatever the groups are there on one side will remain intact. Here I have taken the example of 2-butene. 2-butene can be written as CH3CH, Well, when you place a double bond between the carbon atom, it will be a planar structure. And when it is in plane, the identical groups lying on one side and identical groups lying on opposite side. And this is how we have two types of compounds, cis isomer and trans isomer. This is called cis 2-butene and this is called trans 2-butene. But for this geometrical isomerism, there are certain conditions. One is it should have a double bond, and the main important thing is two groups linked to a doubly bonded carbon atom should be different. Look here. This is the carbon atom linked with the double bond. One is CH3, one is H. That means they are different. But in this case, if you see, there is a double bond, but the carbon atom, doubly bonded carbon atom, having both the groups same. In such cases, there is no geometrical isomerism. For geometrical isomerism, there should be two different groups linked to the doubly bonded carbon atoms. And further, for a given number of n number of double bonds, there can be 2 to the power of n number of geometrical isomers. When one double bond is there, 2 to the power 1, 2 isomers. When there are 2 double bonds, 2 to the power 2, there will be 4 geometrical isomers. This is how the geometrical isomerism arises due to restricted rotation across the carbon-carbon double bond. It comes under stereoisomerism, and stereoisomerism is one in which there is a difference in arrangement of atoms and groups in space. So, because there is a restricted rotation across the carbon-carbon double bond, it exhibits geometrical isomerism.